Task 2. Configure BGP GTSM Generalized TTL Security Mechanism and BGP Authentication to ensure securing BGP. If we have an attacker set here, this attacker can send BGP messages to the backbone network PE2, P2, PE4, even the enterprise routers that run BGP. BGP attacks can make the BGP router overloaded with many BGP messages. Many BGP messages can cause high CPU utilization. The attacker can pretend to be a BGP speaker by sending many BGP packets to the target BGP speaker. The BGP target router like P1 or any real BGP speaker finds that its destination in the BGP packets sent by the attacker, and the forwarding plane of the target BGP router directly send the BGP packets to the control plane without checking the validity of the BGP packets sent by the attacker, and that can cause its CPU to be highly utilized because there are many BGP messages sent from the forwarding plane to the control plane, and these BGP packets are fake BGP messages sent by the attacker. GTSM, Generalized TTL Security Mechanism, protects the router against BGP attacks by checking the TTL value in the received IP header. The BGP messages sent by the attacker has IP header, and this is the BGP message. In the IP header there is TTL or time to live. So GTSM checks the TTL value in the received IP header. If this value doesn't match with a predefined range of the TTL of the receiving router, BGP packets are dropped. In the router, we will configure a TTL range, and if the TTL, which is usually a small value sent by the attacker, the BGP attackers usually send BGP messages from the internet, and because the BGP messages travels all over the path from the attacker side until the target side, the TTL value of the IP packet usually is small value. If we configured a predefined TTL range on the router with a high range, it will be higher than the small value sent by the IP packet of the attacker, and that will cause the router to drop the BGP packet sent by the attacker. Thus, it will protect its control and forwarding plane from receiving many fake BGP messages. To configure GTSM, Generalized TTL Security Mechanism, under the BGP view and the AS, and we press enter, then we add the peer and the peer address, and after that we add keyword valid TTL hops, and we add the configured number of hops. We will configure and set the valid TTL hops to be 1, so we will add value 1 after valid TTL hops. This is the command that will enable GTSM feature, and it configures and set number of hops, which is 1. If we didn't add any value, the default value will be 255. The TTL range will be calculated as following: 255 minus the hops configured plus 1. This is the first number in the range, and the last number in the range is 255. So if we added the configured hops as 1, so 255 minus 1 is 254, plus 1, 255. So the range is 255 and 255. So the TTL in the IP packet of the received BGP message must be in this range between 255 and 255, which means the TTL must be 255. So if we configured the valid TTL hops to be 1 on both BGP routers in the network, between HQ router for example and between P2 router, we have to add the configured hop as 1 to be same range, 255 and 255. That will make the two routers to accept BGP messages from each other, and the attacker BGP messages will be dropped. If we added configured number of hops to be 2, that means the valid numbers of hops will be 254 and 255. Any other TTL numbers smaller than this range will be dropped. Another level of security can be added to the BGP, which is BGP authentication. We will add BGP authentication between BGP speakers. That will authenticate only authorized BGP speakers to communicate to each other using command peer address and keyword password and keyword cipher and the password. Keyword cipher is to encrypt the password of the BGP and to not appear as clear text in the configuration file. The BGP authentication password will be Huawei @123. The first letter is uppercase. So in this task, we have added two levels of security: to configure GTSM with valid number of hops as one that is needed to each peer, and to configure BGP authentication. Even if the attacker can send an authorized TTL, it will be hard for the attacker to know the configured BGP password. Before I copy this script, I will review the BGP configuration on P1, display, current configuration, BGP, and here we had eBGP maximum hop as 2. This is because the BGP pairing between P1 and P2 is established over loopback address, which is not directly connected interfaces between P1 and P2. This is why we had to add eBGP maximum hops as 2. I will remove this command and I will add GTSM feature and BGP authentication password. GTSM feature can be enabled and can replace the function of the eBGP maximum hop. Let's remove now eBGP maximum hop 2. System view or system view immediately, and I'll copy BGP and the AS number, and I will undo peer and peer address and eBGP maximum hop, and I will do the same on P2. Display, current configuration, BGP, system view immediately, and I'll copy the BGP and its AS number, and I will undo the peer and the peer address and the eBGP maximum hop. Now I will reset the BGP peering, and I will do the same on P1. After that, I will issue command display BGP peer to check the BGP peer status, and we can find that it's back again to the idle from the established state. It was in the established state because of adding command eBGP maximum hop 2. But I have removed this command, and now the BGP state back to idle, and same on P2. Now I'll copy the prepared script for the BGP security for P1 and for P2. Right click the configuration script for P1, copy, go to P1 and system view immediately and paste here, and back to the script again, copy the prepared script for P2 and paste in P2. System view immediately and paste here, and display BGP peer again, and we can see that the peer now is back to the established state. It was idle before applying the GTSM feature with valid number of hops as 1 and the BGP authentication cipher Huawei @123. We can issue command display current configuration BGP, and here we can see that we have added successfully to the configuration of the BGP GTSM feature with valid TTL hops as 1, and the BGP password doesn't appear as clear text, it appears as cipher. And I will do same on P1, display BGP peer, and I can see that the peering with P2 is in the established state and display current configuration BGP, and I can see here same configuration, and we don't have eBGP maximum hop as 2. JTSM is enough for the BGP speaker to establish peering with another eBGP peer over non-direct connected IPs. This is the script for PE1 and for PE2, for PE3 and for PE4. All routers in this task will be configured with valid TTL hops and with same cipher password. I'll copy these configuration scripts and apply them offline. They are same as we did for P1 and for P2.